Today we will learn about this atomic radius, and this is also called crystal radius or metallic radius. Crystal radius or metallic radius. Atomic radius means what? So suppose this is one atom. So from the nucleus to the outermost electron distance. So from the nucleus to outermost electron. This is the nucleus and the outermost electron. So this distance is called the atomic radius. So for calculation of this atomic radius, so we have to take one metal crystal. This concept for the metal crystal basically. That's why this is called crystal radius also or metallic radius. So in case of metal, so there are many atoms are combined this way. So now this is one atom and this is another atom. So this is the nucleus of this atom and this is the nucleus of this atom. So that this distance is called the internuclear distance between the two crystal or the two metal. Suppose if we are consider the one copper atom, so this is one copper atom and this is another copper atom. So they are joined together. So now the distance between these two, this one from the nucleus of this atom and for the same metal, because we are discussing about the same metal crystal. So the distance is the internuclear distance in case of metal crystal. Now radius is half of the internuclear distance. This one is the internuclear distance, this total distance from here to here, and half of this. Half of this means this from the nucleus to outermost one. So we are basically calculating the atomic radius, that is from the nucleus to outermost electron from the crystal lattice of the metal. So there many atoms are joined together and they create the macromolecule. So that's why the distance between those two atoms is called the bond length, or this is called the diameter, and its half is called the radius, and this is called the crystal radius. Suppose in case of copper, if this copper crystal, if the diameter, if this for the copper, if the diameter, if this is 256, if the diameter is 256 in picometer unit, or we are measuring the radius in different way, picometer, angstrom. So here I am writing the picometer unit. So the radius of the crystal for the copper, that will be 256 by 2 picometer. Clear? So that's why we will calculate. So atomic radius we will calculate from the metal crystal. That's this is called crystal or metallic radius. Clear? Number one done. Next one, another radius is called covalent radius. Next, number two. Next, number two, this is called covalent radius. Covalent radius. Covalent radius written by R covalent. R covalent. This covalent radius basically for the non-metals. For the non-metals, they are overlapping one another. So for the non-metal, covalent radius. In case of homonuclear diatomic molecule, homonuclear diatomic means when the two atoms are similar, or two atoms there is no difference in electronegativity. If we consider the hydrogen atom, that two hydrogen molecule, that two hydrogen atoms are overlap one another. So or chlorine, any non-metal. So these are the homonuclear diatomic. So this is one atom and another atom is overlapped. So the overlapping region. So this is the nucleus and another nucleus. For the homonuclear diatomic molecule or atom with same electronegativity difference. So that times this distance from here to here, this is called internuclear distance. This distance is called internuclear. This is called internuclear distance. This internuclear distance is called the bond length, or this is called diameter. Now covalent radius R covalent, that is equal to internuclear distance internuclear distance by 2. Is clear to you that R covalent equal to internuclear distance by 2 when the two atoms are similar type or two atoms there is no difference in electronegativity. So now how we will calculate? How we will calculate the covalent radius for heteronuclear diatomic molecule? So in case of heteronuclear diatomic, this formula is not applicable because that times two atoms they are the electronegativity difference or two different atoms. Suppose HCl or two atoms there are difference in electronegativity. So that times how we will calculate the covalent radius. So for that one formula is there that is called uh, the Shoemaker and Stevenson equation. So by this equation we can calculate the covalent radius. I am writing this equation here. So in case of heteronuclear, this is for heteronuclear diatomic or heteronuclear diatomic molecule. In case of heteronuclear diatomic molecule, so in case of heteronuclear diatomic molecule, suppose in case of HCl, so there how we will calculate the radius, covalent radius. These are the similar atoms, the different atoms are there. So for that we can calculate the radius by Shoemaker, this is your scientist name, and Stevenson equation. So by this equation we can calculate the diameter. Suppose this atom is A and B, so or here I am taking the examples of HCl. But if the atom is A and B and there A and B are the two different atoms, A having higher electronegativity and then B, A greater than B. That's the way. So electronegativity of A is greater than the B. So then how we will calculate the covalent radius for that molecule? So diameter of this AB molecule, that is equal to radius of A plus radius of B. But for the difference in electronegativity, one factor will be eliminated from here. So minus, because there are some difference in electronegativity, that's why this is 0.09 into xi A minus of xi B. So this xi A and xi B, this is the electronegativity of A and B, and the difference between these two is the xi A minus xi B, where electronegativity of A that is greater than the B. Clear? So by using the formula we can get the diameter. Diameter means called the bond length, and after that you can find out the radius. So diameter of AB molecule, this is equal to radius of A molecules, radius of B molecules minus of 0.09 into xi A minus xi B, where xi A minus xi B, this is called basically difference in electronegativity. Next, another radius is there. This is the number 3. This is called van der Waals radius. This is called van der Waals radius. This van der Waals radius basically for two distance between the two different molecules. Means suppose this is one molecule, this is one molecule. This is also for the non-metal. Suppose this is one molecule and nucleus, and this is another molecule is there. This is another molecule. So there are two different molecules are there. So now the distance between the two different molecules, this distance, this is called van der Waals distance. Distance between these two molecules are called van der Waals distance. So this is called van der Waals. This is called van der Waals distance, van der Waals distance, this one. So now half of the van der Waals distance, if we make this half, this total distance from here to here, this is called the van der Waals distance. We have learned in the junior classes that this is called the intermolecular distance. So in case of solid, the distance is closer, and in case of gas, this is far away. So basically we are calculating for the solid. So now for the solid, these two molecules are closer to one another. So the distance is called the van der Waals distance. Now the radius is van der Waals radius is r van der Waals. This is called r van der Waals, that is equal to van der Waals distance by 2. So this is called van der Waals distance, van der Waals distance by 2. Clear? Achha, now if you compare the crystal radius, van der Waals radius and covalent radius, how you arrange them? In case of the atomic radius, that crystal radius one, that radius to from the nucleus to outermost one. At covalent, there is an overlapping part. So if you compare between these three, how we can arrange them? Van der Waals radius is the highest. So if you compare, this r van der Waals is the highest. After that, r metallic. And then r covalent. R covalent is the least radius. Why? Metallic radius means this one, that is atomic radius from the nucleus to outermost one. And covalent radius means the overlapping of these two. So now you see, in case of crystal or metallic radius, that is from the nucleus to outermost here. But due to overlapping, covalent radius become less, the half of this internucleus. From here to here, half of this internucleus. So this covalent radius is less. And in case of van der Waals, so this is one molecule and this is another molecule. So this is also distance is greater. So that's why r van der Waals is greater than the r metallic, than the r covalent. Clear?